Hi, I'm Lauren Thomas and I work for Rolls Royce SMR, where I'm an environmental scientist. We're here today at the Learning and Development Centre in Derby to talk about the alpha particle scattering experiment. Imagine, if you will, a tiny, dense core at the heart of an atom. This idea was almost unthinkable almost a century ago. But then came the groundbreaking work of Ernest Rutherford in the early 20th century. And this transformed our understanding of atomic structure forever. Let me take you back to 1909. Rutherford, along with his colleagues, Hans Geiger and Ernest Marsden, conducted a series of experiments at the University of Manchester that would change physics. They took a very thin sheet of gold foil, just a few atoms thick, and bombarded it with positively charged alpha particles, which are essentially helium nuclei. The expectation, based on the prevailing plum pudding model of the atom proposed by J.J. Thomson, was that these alpha particles would pass straight through the foil with only minor deflections. According to this model, the positive charge in the atom was thought to be spread out evenly, like plums in a pudding, with the electrons embedded within it. But what they observed was astonishing. Whilst most of the alpha particles did indeed pass through the foil with little to no deflection, a small number were deflected at large angles, and even some bounced back towards the source. Rutherford described it as if you'd fired a 15-inch shell at a piece of tissue paper, and then it came back to hit you. This was completely unexpected, and this could not be explained by the plum pudding model. So what does this mean? Rutherford proposed a new model of the atom. He suggested that the atom must be an empty space with positive charge and most of its mass concentrated in a tiny central nucleus. The deflections occurred because the positively charged alpha particles were repelled by the concentrated positive charge in the nucleus. The nuclear model of the atom was revolutionary. It laid the foundations of the modern understanding of the atomic structure, where the atom consists of a dense nucleus containing protons and neutrons surrounded by a cloud of electrons. Rutherford's scattering experiment was a brilliant demonstration of how scientific inquiry can challenge existing ideas and lead to profound new insights. It reminds us that sometimes the most surprising results are the ones that propel science forward the most.